going to help me teach today? Ho, 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 ho. Say hi. Say cat. Yeah. Do you like references? Okay. Usually I like to sit on the computer. Sometimes it gets warm. All right. All right, let's get started today. I have a little helper here who you can't see, who I guess is interested in today's topic as well. It's not often that cats are confused, but references are a little challenging. So let's talk a little bit about how they work. So let me actually start at the top. I will get to the question that's posted in the chat, but what we're doing today is pointing out something about Java that's always been true, but we've never really confronted. We've never actually, rubbed our face on this particular aspect of things. When we've been, and it's been hard for me not to do. This is kind of the point of the class where I can kind of like flip a certain switch when it comes to terminology, because in the past, I've been wanting to say things like reference variable, the variable refers to whatever, and I've been avoiding doing that. We've been sort of intentionally vague about when I create a variable that stores an object, what does it actually store? And so today we're going to become more clear about that. We're also introducing a topic that is just tremendously important throughout computer science. References are a concept, an idea that gets used in a variety of different programming languages and in contexts outside of programming languages as well, including some that we'll talk about later this semester. So the first starting point here is to kind of look at this example where I've created this person class, following our encapsulation pattern, which makes it 12 lines long. It has a name that you can set when you create it and a getter for that name. A setter for the name. Both a getter and a setter for that name. That's why it's 12 lines long. So, and then down here, I create a person object. So at this point in my program, I have one person that I've created, and the person's name is Geoff. And I have what we're going to now refer to as a reference variable over here So now we can kind of refer to assignments, which we've always been looking at really carefully. So on the right side of this assignment, I'm creating a new person object. Whenever I see the new keyword, an object instance is being created. If I don't see new, no object instance being created. And that's a really important distinction that we're going to start drawing today. So on the right side of this assignment, I've created a new object. I constructed it. I passed a string. So now I have a person object that contains the string Geoff. And I save, what gets saved into this variable on the left is not the object. It's a reference to the object. That's what we use when we use dot notation. Dot notation is following the reference in order to call a method or adjust a field value or whatever. So line 13, I'm creating a new person object on the right and assigning a reference to it into the variable on the left. That variable being of type person means that it can store references to person objects, and it turns out, which we'll come back to tomorrow, to anything that can be cast to a person. So anything that has an is-a relationship with a person. If I have classes that extended person, I could also save a reference to those classes in this reference variable me. But for now, I've just got this one class. Okay, that's stuff we've been doing so far. And we've been saving those reference variables. We've been using dot notation to follow the reference and to manipulate the state of the object. But now what I'm doing is something new on line 14. And what I'm doing here is I'm assigning me to you. Now again, what happens here? What does this line actually do? And that's what we're going to start to become more clear about today. So what is this line actually accomplishing? I am not making a copy of the person object. There's no new person that's created here. When you don't see new, there's no object being created. And so on the right side of this assignment, I don't see new. Instead, I see this variable me that contains a reference to the person object that was created on line 13. So what's happening on line 14 is that I'm copying the reference. So I use a couple of different metaphors throughout this lesson, and I think this is actually a good place for metaphors because these are pretty accurate. So it's almost as if on line 13, I'm constructing a house on the right side and saving the address of that house by writing it down on a piece of paper on the left side. Then on line 14, I take the address that I have written down and I copy it onto another piece of paper. I don't have two houses. I got one house. I created it on line 13. When you don't see new, no new object is being created. Instead, what I did is I copied the reference, the address. So now I've got two pieces of paper. Maybe I give one to one person, keep one for myself, with the address of the same house. Okay, so that's the critical part here, is to start to learn how to distinguish between a reference and the thing it refers to. So in this case, the thing it refers to is that new person object that was created on line 13. I've only got one of those, but after line 14 completes, I've declared two reference variables that can both store a reference to a person. In this case, they both refer to the same person because I've only created one person in the program. I only see new once. And then when I set up my new reference variable on line 14, I copy the reference from me to you. And so now both me and you refer to that single person object I created with name Geoff. I can verify this by making a change to the object and showing that that change is visible to both references. So that's what I do in the next two lines of this small example. And again, these are, we're still in the mode together where we're breaking down Java line by line, statement by statement. And even a little set of 4 lines here can, at this point in your education into the Java programming language, still contain a lot of new ideas. And so I don't want you to just gloss over that, whatever. If you understand these 4 lines, and there's other 4-line sections later or 6-line sections, and really think through what's happening and start to build up your own mental model. I've got some pictures that I'll show you later in some of the lesson walkthroughs, but what's really important is to be able to start and develop your own sort of mental model and your own intuition about how things look or how things are behaving. So let's confirm that these two references refer to the same object. And the way I'm going to do that is I'm going to make a change to the object using one reference, and then retrieve the contents of the object using the other reference and show that both if I make a change with reference A, then reference B sees that change. So again, this is like you have two addresses to the same house. You give one to a painter and one to a plumber. If the painter gets there first and paints the house yellow, when the plumber shows up later, the house is yellow, right? They both have an address, only one house. Any changes that you make using that reference are visible to everybody else who has a reference to that same object. And so on line 15, I call setName using U. So internally what Java does is says, okay, well, U is a reference. What object does it refer to? It refers to the object that I created on line 13 when I ran new. That object started off with the name Geoff, but it has a method called setName that allows me to adjust the name. So after line 15 completes, that single object, so that single object I had the name Geoff, and now it has the name Fantastic Student. There's only one object here. I only see new ones. Line 16, now I use the other reference, me, to refer to the object. And again, Java looks up what object does it refer to. Okay, it's that same object that was created on line 13 and modified on line 15. So when it started off, it had the name Geoff. Then I called setName, which modified the name to be a new string. And so when I call line getName on line 16, I see the new string. One of the things that makes this hard to understand in Java is that references aren't really visible to us as the programmer. There's no way to get Java to just tell you like what's inside the reference variable. The closest you can come, you can sort of do this, and I'll show you how. So let's do this. Let's do system.out.println me. Remember this that we saw before when we hadn't overridden toString? We saw the name of the class and then followed by this hexadecimal stuff, right? That hexadecimal content is the closest that you're going to get in Java to being able for it to tell you what the thing refers to. And so if I run both, now every time I run this program, you're seeing different addresses. So the reference isn't the same every time I run the program, but what I want to point out is that what's being printed is the same for me and you. And that's a hint that they refer to the same object. Now let's look at what happens if I create another object. So now you'll see they're different. Okay, so this is the closest that we can get. If we have a class that hasn't overridden toString, and we print it out and look at the contents of that string, we see a little bit of a hint about what the content of the reference is. But this is kind of the only way to get Java to cough up this information. And so again, when you and me refer to two distinct person objects created using new, those reference contents will not be the same. When they refer to the same object using me, using reference copying, then you'll see the references are the same. Okay, so that's my opening monologue. Let's take some questions. So it says, when can you have a.b equals true without having a, so I don't think you mean modified, right? Remember, when you design a class, so let's talk about this. So the question is, when can I have, so let's print system.out.println me.u.equals me. And the answer is true. The answer is true because these literally refer to the same object. And we'll come back and review this again tomorrow, but it's a good point. The default object equality method is essentially equivalent. If I don't override equals, it's equivalent to this. It's testing reference equality. It's testing literally do these refer to the same object. However, classes in Java can override the equals method, right? And so, for example, let's look at strings, right? So let's say string s is equal to new string test, and we'll say string t is equal to new string test. No. Now, these strings are equal. I mean, I think we could all agree upon that, right? They should be equal. They should be considered equal. They have the same content. However, if I test them using reference equality, they're not equal. And the reason is there's two separate string objects with the same contents. Now again, however, if you were like checking passwords or something like this, you would want these two strings to be considered equal. They have the same contents. And so in order to check them properly, we use the dot equals method. Now, different classes can define dot equals in a way that's appropriate to them, but that's up to them. You shouldn't if a class has the dot equals method, you should use it. That's why we tell you whenever you compare two objects, always use dot equals, because either one of two things will happen. Either the class will have defined its own notion of equality, and if it did that, you should use it, right? The class is allowed to define what it means for two instances of that class to be equal. If it didn't override that, then what you're going to end up with is that object default definition of equality, which is just reference equality anyway. And so you should never, short circuit the process. Again, like if you were writing something to check passwords and you used reference equality instead of object equality or instance equality, your program wouldn't work. Nobody would ever be able to log in, right? Because it's very likely that, those two strings, the one that you're checking against and the one that the person's applied, are actually two different Java objects. And so what we want to test is whether their contents are the same. And so whenever we compare objects for equality, we always use dot equals. That's our convention. So yes, it's a good point. In order for s dot equals t to be true when s double equal t is false, that means that the class has overridden equals. But if the class is overridden equals, we should use it, right? The class is allowed to define. When you define your own classes, Java allows you to define what equality means. And if you don't use that definition, you're going to get, again, very unintuitive results, right? So again, people lost points on this before with some of the rotation things because they were checking for the empty string by doing double equals empty string. Same problem, right? I could have two strings, right? So if I have this is an empty string and this is an empty string, these two strings are equal. But if you check them like this, you're not going to consider them equal, and you're going to do something wrong with the code that follows. So yeah, we want to use the dot equals method. If the class provides an override, then we get the behavior that the class desires. If the class doesn't provide an override, then we get reference equality anyway. And so there's almost no reason to ever use reference equality when you're comparing two objects. There's probably a few places where you might need to, but in general, the answer is no. You want to use dot equals. Okay, so we can go through. I'm happy to kind of go through any of the examples here. Like I said, I think this is a topic where thinking about physical analogs is probably great, right? In the sense that trying to think it through, like, okay, well, what do I know in the world that kind of behaves like a reference, and actually that will also give you a little bit of insight into what it means to translate a reference or dereference something, right? So a phone number is a great example of a reference. I can give out 10 people my phone number, I still only have one phone. And if one person calls and I'm on the phone with them and somebody else tries to call, they get a busy signal. And so they can tell that they're all accessing the same device. At the same time, if you think about what happens when you actually place a call, many of you don't know exactly how this works, and I'm not sure I do either. But the idea is that the phone company has to do a bunch of work, right? When you type in 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, somewhere someone has to understand the mapping, right? Someone has to maintain that mapping between that number and an actual physical device. So I don't know if that's a real phone number or not, right? If it is, I feel bad for the person because they probably get a lot of prank calls, right? But if you dial 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 and hit send, the phone company has to translate the reference. They have to dereference it. This is sort of equivalent of dot notation, right? Like the phone company has to figure out, oh gosh, somewhere in the world, the United States, wherever, is a phone that should ring now because somebody typed in that series of digits and hit send. Where is that device? Which device is it? Where is the device? How do I send it to Signal so it starts ringing and stuff like that? And so that's sort of the process of the phone company dereferencing something. When Java does this internally, the process is obviously completely different because it's a completely different idea of a reference. But on some level, it's not that different in the sense that Java has to maintain has to know how to dereference something. So when you use dot notation, it has to be able to take that reference and actually locate the actual object that it refers to. At the same time, I think one of the more important concepts here is this distinction between the reference and the object. There are really two things in our program. Part of the thing that's tricky about these objects is that we can only access them through a reference, right? So it's difficult to think of them as two separate entities. But some of these pictures, so I'll pull up, I'm borrowing some of my old diagrams from a previous semester, since these took me a long time to do, and they're good. So, let's see here. For example, so here, right? I think this is a nice, a nice diagram. I made it, so obviously I have positive feelings about it. But if you look what's happening here, right? I've got two things here. I have a reference variable named me, and I have this object over here that was created using the new keyword. And there really are distinct things in your program. They kind of live in separate places. But because we can only ever access this person object using a reference, it's difficult to think about them conceptually as being different. But they are, right? And then again, once I add another one, this I think is another one of these really important ideas. This is sort of like taking a phone number and copying onto another piece of paper. One phone, two numbers, right? And on some level, the idea behind a reference, needing a reference to access something is not really that weird. I mean, my favorite example is always like, if you have a house and no one has an address to it, does it actually exist? Nobody knows where it is. I mean, there's probably some forest somewhere on Earth, some remote place, where there's a house sitting there, probably not in very good condition because nobody's been there in a while. And nobody knows where that house is. Maybe the people that used to go there to go hunting or something, passed on and didn't tell anybody, forgot to tell, their kids in the will, like where the secret hunting cabin was. And now it's just sitting there. And because nobody knows where it is, it might as well not exist. If you can't find it, does it actually exist or not, right? Like we're talking about it in the hypothetical. I'm just saying, given all the weird stuff that seems to happen in the world, the likelihood that a place like that exists is pretty high. But there's no way to know, because in order to know, you'd have to know the address, and if you knew the address, then you know where the house was. But there's probably, like I said, some lonely house, maybe more than one actually, all across the world in different places, just sitting there. And at some point, someone will discover it because they'll be hiking through the forest and they'll stumble into it. But until then, that house might as well not exist because no one knows where it is. And so if I don't have a reference to something, if you invite me over to your house to hang out, you don't tell me where it is, I might as well not have been invited. I can't make it there. If you tell me, call me later, we'll chat on the phone. I don't even remember, same thing. Might as well not. You might as well not have a phone. If you had a phone and nobody knew the number, it would probably not ring. You could use it for other things. People use their phone for all sorts of stuff that doesn't involve receiving calls now. But anyway, so the idea of having multiple references to something and the idea of only being able to get at that thing through a reference shouldn't be too terribly weird for us in our programs. Daily socials today, I think we'll do something this week. I've been sort of doing those like kind of just whenever, whenever the mood strikes. Maybe we'll try to do it a little earlier in the week this week, but yeah, we'll do some more office hours this week at some point. I'm not exactly sure when, but yeah, and I'll send out an email maybe a little bit earlier than before. All right, other questions. So here's our, this is kind of the reference copying example. I should also, I can just go through this, right? So these other kind of like observations. So references are one of those places where this is one of these concepts that, like I said, we've been kind of hiding from you because I didn't want to confuse people unnecessarily. But as soon as we introduce this, I hope that there's some other stuff that starts to make a little bit more sense, right? So null, for example. Null is the absence of a reference. Null means that a variable that is able to store a reference does not store a reference. So again, if you're like, hey, call me later, and you give me a blank piece of paper, not going to work very well. Now, the computer doesn't handle that very well. If you gave me a blank piece of paper, I'd be like, okay, I'm not going to make the call. And instead, the computer, like, just, I don't know, picks up the phone and hits send or hits all zeros or does something stupid and crashes, right? Computers aren't as good at handling the situation. But the idea is that that piece of paper you gave me is supposed to have a phone number on it. If I want to call you, it's got to have a phone number. If you give me something blank, then, you know, that's sort of the equivalent of null. There's nothing I can do with that information. But it's also empty, right? So that's another way of thinking about it. Now, that piece of paper, you can still store a phone number. You just have to write it on there. But right now it doesn't. And so if I try to make a call based on that lack of information, it's not going to go very well. What's the point of having null? Great question. Yeah, so this goes back, if you look at that lesson that we did about null and the $1 billion mistake, it's a good question. So there are definitely type systems that do not have null, in the sense that if I create, you can imagine that if I create a reference variable, I can always be required to store a reference in it. So that reference variable, when it's declared, must store a reference. And on some level, the problem that you get into with Java is here's another place where this can happen, right? So if I do, and then I say string s, and then I say example e is equal to new example, and I system.out.println e.s, I see null. So what happens here is my example class hasn't either initialized this string statically, which I can do like this. So if I want s to not be null, I can do that. Or I could create a default no argument constructor that does the same thing. So in each case, I'm preventing the string from being null. You know, the answer to that question is, according to the person who created null, it simplified certain things in the design of the programming language that they were working on at the time. Now, you know, I'm trying to think. I mean, there are, so typically, you know, Java programming and sort of modern approaches to Java, there's a lot of sort of programming patterns and sort of various tools and things like that that have been designed to help programmers avoid problems caused by null. This goes back to that $1 billion mistake, right? So languages like Java that have a notion of null, and many languages have some equivalent to null. In C and C++, they have a notion of null, and it causes similar problems, crashes and things like that. There's a lot of language. Python has a notion of null. I don't know why Python has a notion of null. It's like well, Python's kind of an old language, so it has a notion of null. Now, more modern programming languages have adopted tools and techniques and I shouldn't say advanced. So the compiler can actually can help you out quite a bit here. And there's newer alternatives to Java that do a lot more to help you prevent from making mistakes with null. And so Kotlin, which is sort of a modern alternative to Java that interoperates with Java but has its own syntax, one of the big design goals of that language is null safety. So Kotlin is really focused on helping you make sure that you don't have an error with null. So some of the things that Kotlin does. So first of all, when you create a variable in Kotlin, you have to tell Kotlin whether or not it's nullable. You tell Kotlin whether or not that variable can ever store null. If that variable can never store null, then there's a lot of, so for example, if this string here could never have a null value, you can imagine that when I'm programming with instances of example, there are certain places where normally I would have to check for null that I don't have to, because I know that that variable can never store null. Now, when you mark a variable in Kotlin as never being able to store null, you have to follow through. So when you create a string, you have to assign it a value immediately. If you don't, the compiler complains and it won't compile your code. The other thing Kotlin does is when you are using a variable that might be null, it forces you to use it safely. So for example, you know, this is my favorite example of Java being Java, right? So, right? And then I can say, you know, and then I have a null. I mean, this is just inane. right? I mean, it does not take complex compiler techniques to not allow you to do this, right? Like I created a variable on line 1 and I initialized it to null, and the next thing I did was try to dereference it. So modern compilers can do better than this. In Kotlin, what would happen is Kotlin would know that S could be null, and it would force me to dereference S more carefully. So Kotlin has some additional syntax for working with variables that could be null that are designed to prevent this type of problem, right? So Kotlin will not allow you to just blunder in to a null pointer exception. If the variable can store null, Kotlin says, okay, well, you've got to handle it like with some hot pads, right? You've got to do some things with that variable to make sure that if it does happen to have a null, contain null, the program doesn't crash, right? Usually, when you're working with variables that are nullable, you have some idea of what to do if the variable is null. The problem with Java is that it doesn't help warn you about these situations, right? So again, I can do something like this by accident, right? No programmer does this on purpose, right? And this, I mean, no programmer does this. It's more likely that you wrote a method called, and again, this is a dumb method, and it took a string as an argument and was just supposed to return, again, you wouldn't do this because this is a one-liner in Java, so I don't need a special method to do it. That seems a little silly, right? And then if I call this, no, come on. Now I have the same problem, right? This is more common, right? Where I have a parameter, or I have an object field, or something that's a string or an object reference variable that can store null, and I forgot to check, right? And we've showed you ways of avoiding this type of problem, but people still do make this kind of mistake. There are some newer languages that make it much, much harder, though. Again, like I think, there are some places where I think having null can be sort of defensible. I think what's more of a problem is in Java is the fact that the compiler and the language itself don't provide you with a lot of help for working with null. Now, JavaScript has null. I'm just thinking of all the languages that have null. I mean, there's a whole bunch of languages from that time period. So this is one of these fun stories in language design, right? There's a whole bunch of languages from that time period that have this problem. When new languages emerge, they tend to solve problems. Particularly popular ones. Popular languages tend to solve problems that the community of programmers has been dealing with for a while, right? So when Java, we'll talk about this later this week, actually. We'll talk about kind of the thing that was really kind of, for a mainstream language, quite novel about Java when it came out. So when Java came out, it solved a particular variety of problems that older languages had. But it didn't solve all of those problems. Clearly, null is a problem that it didn't even try to solve, right? Because I can write these two-line programs that crash with null pointer exceptions. So when Java came out, null didn't solve null, solved some other problems. Same thing with JavaScript, came out around the same time, right? Solved some other problems, I wouldn't argue JavaScript initially didn't solve any problems. It was just something that you could run in the browser. But anyway, Python, same thing, solves certain problems, doesn't solve other problems. Null is one of these things that over time, the kind of programming, the computer science community has realized what a problem this is. And so there are new languages that have emerged, including Kotlin, including some other more modern languages, that have better solutions to null safety. And that's one of the, again, that's to me one of the things that's so fun about computer science as a field, right? Is that, even within my just 2 decades of working in this field, I've seen huge improvements and advances in technology, right? Including technology that I use every day, right? I mean, the programming languages I write in now when I'm building stuff for you guys to use are better than they were 10 years ago, and are way better than they were 20 years ago when I was learning this stuff. So the progress marches on, and it's not always linear, and sometimes new languages create more problems than they solve, or don't solve things in a beautiful way. But I would argue we've made a lot of progress. And this comes about because people keep having problems, right? I mean, computer science on some level is a very practical field. Like, you try to solve problems that people are having. People continue to struggle with null. time after time, lots of crashes, lots of failures, lots of bugs because of this. And so finally somebody was like, look, we're going to take this seriously, and we're going to design some new language techniques, some new approaches to make sure that we don't have this type of problem going forward. So anyway, you know, I think Null in many ways is widely regarded as a mistake, but it's just one that has taken us a while to fix. But we're getting there. So great question. Other questions. So there's a couple of, you know, practice examples here about how to use references and sort of visualize what's happening when you use references, including copying and swapping, and I'll let you guys work through those. We'll have some more of those tomorrow. So tomorrow's lesson is more references. We'll introduce this idea of polymorphism on the reference variable and kind of relate these two concepts, right? So polymorphism, which some of you might still be a little fuzzy about, references, which you might be a little fuzzy about. So hopefully those two fuzzy things will become clear when we pair them up. But there is there's a connection there, right, in terms of the type of the reference variable and polymorphism as it's experienced, at least sort of subtype polymorphism in Java, which is the only kind that we've been working with. All right, other questions. I will stick around for a couple of minutes to see if there are other doubts or questions. Yeah, like I said, we'll get one of those. We'll get one of those set up, and we will for this week. All right, any last questions on today's material? Like I said, I mean, this is important stuff, right? So if you haven't already, please go through the lesson, look at the examples, particularly go through some of the interactive bits that have some diagrams in them carefully, just to start to try to I typically don't try to explain things with pictures in this class when they're not appropriate, but there are a few places where they do work pretty well. This is one of them. So yeah, I think that'll help for some of you that are struggling to kind of wrap your mind around this. This is not an easy idea, and one of the reasons why we do it in this class And one of the reasons why I kind of harp on it a little bit is because it is so powerful and it's so ubiquitous. References just get used in a variety of places, and on some level, like the process is very similar, of dereferencing references of what they mean and stuff like that. Great question. No, see, these are the kind of questions I like. This is great sort of. How does Java integrate with other languages like JavaScript and HTML? It doesn't really. It doesn't. Well, okay. So fair enough. How does Java integrate with those languages? I would say it doesn't really integrate with them. Java doesn't really interoperate directly with HTML and JavaScript and stuff like that. Instead, what you do is you create ways for a piece of code written in JavaScript, for example, and a piece of code written in Java to communicate with each other. And we'll talk, actually next week, we'll start talking about interfaces, but later in the class, we'll introduce you to the idea of web interfaces. And that will hopefully start to make this a little bit more clear. But I can use an example, right, that's drawn from your guys' daily experience of the class. So for example, all of these playground examples that you guys work on that are part of the site. First of all, the whole site's powered by JavaScript. That's how the web works today. There are movements to build in support in browsers that would allow people to use other languages, and there's some fledgling support for this in certain ways, right? So I'm not saying that you have to use JavaScript if you want to develop for the web, but it is still the dominant language that people use for web development, because the real reason for this, which I can show you just really quickly, is that, let's see here, let me pop this back in, is that your web browser runs JavaScript. Your web browser is a JavaScript interpreter, right? So I can do like this, and then I can do this, or I can do console.log. That's the equivalent of println. So this runs code. Your browser runs code. Maybe you didn't know that, but it does. And actually, that's how most of the web works these days. So when you go to the CS125 website, we just don't send you, content. We actually send you a whole bunch of code. And that's what, so for example, that's what powers these little in-browser editors, right? Like what causes the brace matching to work or the syntax highlighting, whatever. It's all code that runs on your computer. Now, when you run this code, right, when I actually go ahead and let me use a different value here so we can see what changes, right? So when you run this, now we actually need to run some Java code. JavaScript doesn't run Java code. So what we have set up is there's a server located in our private cloud. And what we do is we take your code that's sitting right there in front of you, that 4 lines. We send it over the internet in a message. We'll talk about how this works later, but we send it to this other piece of code, right? So we've got a piece of code running JavaScript sitting right in front of you. We have a piece of code running Kotlin, a variant of, I shouldn't say a variant of Java, a successor to Java, but that interoperates with Java. We have a server running somewhere else in our private cloud. It's not sitting in front of you. We take your code, package it up nicely, send it back to that server. That server compiles it, runs it, grabs the output, sends it back, and we show it to you. That's how that works. So on some level, that's interoperation between JavaScript, what's running in your browser, and Java, which is, or Kotlin or whatever. It could be in Java. It's in Kotlin because Kotlin's more fun to use. But anyway, so there's a server on the back end that's doing this, and then stuff running in the browser. So those are the two components. How they interoperate, we'll talk about later. But essentially, you can think of it like they're sending each other messages. It's almost like being able to make a function call. And we'll talk about throughout portions of the rest of the class various enabling technologies that allow that to happen. In fact, we're actually going to get into some of that a little bit later this week in terms of like how do we pass information in between two computer programs when those computer programs aren't even running on the same machine, right? The JavaScript's running on your machine. Our snippet runner is running on a machine that's located in the Siebel Center or somewhere on campus. I don't even know where the machine is, right? I don't care, but it's running one of our cloud machines. So date the code, we send it as a message across the internet to this other computer that does some work and sends it back. Most of what you experience through the web today is built with that model, right? So for example, if you use Gmail and you click that little icon that says refresh my mail, that's what happens. Your computer, which is running a JavaScript program, sends a little message to some Google server somewhere that says, I want more mail. And the Google server says, I ain't got it. Or, oh, here's a new message, and sends you back a little bit of information. And then the JavaScript program that's running in front of you updates the UI to show you the new message, or does nothing if there's something new. So that's kind of how this typically happens, and that's kind of how you typically see interoperation between various types of technologies on the web. HTML, which you also asked about, is a very different story. HTML is something that's known as markup. It's not a programming language, and the distinction between those two may not be completely clear, but one way to think about HTML is like it's a set of instructions about how something is supposed to look. It doesn't actually perform any computation. There is code that's typically involved in generating HTML so that your page looks a certain way. But the HTML itself is not computer code. It's usually something that's generated by computer code, but the browser takes it and understands how to set it up on the page. We don't do web development in this class mainly because Java isn't a good fit for it. However, so you guys start working on your Android project, we will talk about layout, right? How do things, so for example, if you're looking at the 125 website, how is it organized, whether there's one column here, this column, why is there a certain amount of space between different things, why is the text a certain size, why are the buttons a certain color, why does the button do a certain thing when you click on it, all that stuff, right? Android has its own ways of doing this that differ from the ways that are used on the internet, but fundamentally reuse a lot of the same ideas. And so you guys will have a chance to kind of dig in. We're going to give you a simple app, and we'll look at some of the same markup in the app and talk about why it looks the way it does, right? Like, what are these features, and why does this icon go here instead of there, and what if I wanted to make it look this way? And that turns out to be surprisingly difficult. Getting stuff to look even halfway decent turns out to be a big design challenge. It's a lot of fun because at the end of the day you get something you're proud of. But yeah, it's work. But it's super cool. But great question. All right, so I am done for the day. Thanks to everyone for joining me, and I'll be back tomorrow with another lesson this time on polymorphism and references. So that'll be cool. Ziz also wants to say hi. She wants to say bye, everybody. You want to say bye-bye? You're standing on my computer. Is it because it's one? Okay. Meow, she says. See you tomorrow.